Hi, I'm Jim Anderton, Director of Content at Engineering.com. Volkswagen. Volkswagen has not one problem but two. The first, and the big one, is how to salvage their reputation after the global PR disaster of the firm's absolutely reckless behavior by using defeat software to cheat US EPA emission control tests. Now, the second problem is in some ways a lot tougher, and that's what to do about it. Now, it goes without saying that the reason for cheating on the test is that there is no way to achieve legal emission levels at the power and efficiency delivered by the suspect engine. And why only that engine? To understand that, we have to consider what's going on inside the engine's combustion chamber. So it's more of a generic look at the problem. Take a look at this. Here's a generic chemical equation for what's happening when motor fuels are burned in an automotive combustion chamber. Now, I know the chemical equation isn't balanced, but it illustrates the process. Fuel combines with oxygen in the air to produce carbon monoxide, carbon dioxide, water vapor, and of course heat, which is the point of the exercise. Now, carbon monoxide is a deadly killer, so catalytic converter technology was developed to convert it to yet more CO2. Note that CO2 is not a pollutant, although it is a greenhouse gas. Unfortunately, oxygen is only 21% of the air we breathe. 78% is nitrogen, and at the elevated temperatures and pressures of an automotive combustion chamber, the oxygen in the air also reacts with that nitrogen to produce an assortment of oxides of nitrogen that engineers call NOx. NOx is a problem because it's a major contributor to photochemical smog, and the very attributes that make diesel engines so efficient make them potent producers of NOx. Basically, there's no free lunch. To extract the ultimate amount of heat energy from every unit of fuel, NOx will be a byproduct. Now, to remediate this, one strategy is called exhaust gas recirculation. Now, this is widely and erroneously believed to be a reburning of exhaust gases, but in fact, it acts like an inert filler in the combustion chamber's air-fuel charge, reducing combustion chamber temperatures and thus lowering NOx levels. Now, that's great for the environment, but it's terrible for power economy and drivability. Now, modern EGR is mapped and computer controlled to add just the right amount to keep NOx levels in check without making the vehicle undrivable. But if it's power and economy you're after, hamburger helper isn't on the engine's menu. So VW engineers neatly created an algorithm that detected when the car was undergoing an emissions test, then drastically increased the amount of exhaust gas recirculation, producing very clean emissions. In every other operating mode, like the real world, EGR was reduced dramatically, resulting in greater power and economy. Now, one possible fix for VW is to remap the engine control algorithm to simply add more EGR, but the result will be lowered fuel mileage and reduced power, something your customers won't take lying down. But there is another way. It's called selective catalytic reduction, or SCR. The chemistry is complex, but to put it simply, a special catalytic converter converts the NOx back to nitrogen gas and CO2, neatly solving the problem. But there's no free lunch here either. SCR needs a steady stream of urea in the exhaust stream to make the system work. The urea solution is more commonly called diesel exhaust fluid, and it's used in millions of diesel-powered light vehicles and heavy trucks. Next time you pass a large Class 8 diesel truck, look for the small tank next to the fuel tank with a blue filler cap. That's the tank for diesel exhaust fluid. So VW's logical solution is to add urea injection to the affected engines. Now, unfortunately, the underhood area in these vehicles is already packed, making packaging difficult. Plus, the revamped exhaust system and plumbing may prove ruinously expensive to develop, manufacture, and retrofit in the field. Plus, it'll be necessary to convince owners to have their retrofit installed, then carry the diesel exhaust fluid with them and replenish the tank periodically. Now, fortunately, a little goes a long way, and the fluid can usually be topped off during scheduled maintenance. Now, Chevrolet's excellent Cruise diesel, a competitive model to VW's Golf and Jetta line, uses this technology successfully, as do many other light-duty diesels. Look for a crash program at VW to engineer a retrofit of urea injection systems in all the affected vehicles. Now, it'll be expensive, damn expensive, but unless Volkswagen can cut some sort of deal with legislators, it may be the only technical solution for millions of VW diesel owners.